Welcome. Today we're diving into the world of disinfectants and antiseptics. These agents play a crucial role in maintaining hygiene and preventing the spread of harmful microorganisms. But what exactly are they and how do they differ? In this video, we'll explore their definitions, classifications, ideal properties, and mechanisms of action. By the end, you'll have a clear understanding of how these substances work and why they're essential in healthcare and daily life. Let's start by defining what disinfection really means and why it matters for our health and safety. Disinfection is the process of destroying or removing microorganisms to a level where they are no longer harmful to health. Unlike sterilization, which aims to eliminate all forms of microbial life, disinfection focuses on reducing the number of pathogens to safe levels. This process is vital in hospitals, laboratories, and even at home, especially during outbreaks of infectious diseases. Disinfection helps prevent the transmission of bacteria, viruses, and fungi, ensuring that surfaces and objects are safe for use. Now let's look at the key agents involved in this process: disinfectants and antiseptics. Disinfectant is a chemical agent used to kill microorganisms, except for spores, certain viruses, and prions, on inanimate objects. Disinfectants are applied to surfaces like tables, metal instruments, and floors to reduce the risk of infection. They work through physical or chemical processes, targeting the structures or functions of microbes. It's important to note that disinfectants are not meant for use on living tissues, as they can be too harsh and potentially harmful. Next, let's see how antiseptics differ from disinfectants. Antiseptics are agents designed to destroy or inhibit the growth of microorganisms on living surfaces, such as skin and mucous membranes. Unlike disinfectants, antiseptics are formulated to be safe for use on the body, making them essential for wound care, hand hygiene, and surgical preparation. They help prevent infections by reducing the microbial load on living tissues without causing significant harm or irritation. This distinction is crucial. While both disinfectants and antiseptics control microbes, their applications and safety profiles differ significantly. Let's clear up some common misconceptions. First, it's false that disinfectants kill all microorganisms. Some, like spores and certain viruses, can survive. Second, alcohol is not most effective at 100% concentration. In fact, 70% is optimal for killing microbes. Third, antiseptics and disinfectants do not differ only in strength. Their intended use and safety profiles are also different. Understanding these facts helps us use these agents more effectively and safely. Summarize: disinfectants are used on inanimate objects to kill most microorganisms, while antiseptics are used on living tissues to prevent infection. Both play vital roles in infection control, but their applications are distinct. Choosing the right agent for the right situation is key to effective hygiene and safety. Let's now explore the ideal properties that make a disinfectant truly effective. Ideal disinfectant should have a broad spectrum of action, meaning it can target a wide range of microorganisms. It must remain effective even in the presence of organic matter, be non-toxic and non-corrosive, and work across a wide pH range. Other important properties include being cytokilling organisms, soluble in hard water, chemically stable, fast-acting, non-inflammable, and environmentally friendly. High penetrating power ensures it reaches all surfaces, making it reliable in various settings. Sterilization and disinfection are often confused, but they are not the same. Sterilization is a process that destroys all forms of microbial life, including spores, which are highly resistant. Disinfection, on the other hand, does not kill spores. This distinction is critical in healthcare, where certain instruments must be sterilized, while others only require disinfection. Understanding the difference ensures proper infection control and patient safety. Let's take a closer look at how sterilization and disinfection differ in practice. Sterilization is used for surgical instruments and materials that enter sterile body sites, while disinfection is suitable for surfaces and equipment that do not require complete sterility. This visual comparison helps clarify when each process is appropriate, ensuring both effectiveness and safety in various environments. Disinfectants can be classified based on their physical consistency: liquids and gases. Liquid disinfectants include alcohols like ethanol and isopropyl alcohol, as well as phenols. These are commonly used on surfaces and laboratory equipment. Cresol, a more powerful phenol, is effective at lower concentrations. Gas disinfectants such as ethylene oxide and aldehydes are used for instruments and sensitive equipment that cannot be immersed in liquid. Each type has its own advantages and specific uses. Disinfectants are also classified by their spectrum of activity. High-level disinfectants like aldehydes and certain gases are used for critical instruments such as endoscopes and surgical tools. Intermediate-level disinfectants, including alcohols and iodophores, are suitable for items like laryngoscopes. Low-level disinfectants such as quaternary ammonium compounds are used for non-critical items like stethoscopes and ECG machines. The choice depends on the level of microbial risk associated with each item. A mechanism by which disinfectants work is by destroying the cell membrane of microorganisms. This action is especially effective when combined with water. For example, 70% ethanol and isopropanol are commonly used as hand disinfectants because they disrupt the microbial cell membrane, leading to cell death. This mechanism is fast and reliable, making alcohol-based disinfectants a staple in healthcare and daily hygiene. Another key mechanism is the denaturation of cellular proteins. Disinfectants like alcohols and phenols, including chlorocresol and chloroxylenol, disrupt the structure of cell wall proteins and enzymes. Popular products such as Dettol and Lysol use these compounds to effectively kill microbes on surfaces. By altering protein structures, these agents render microorganisms inactive and unable to reproduce. Some disinfectants like ethylene oxide gas and formaldehyde act by damaging the nucleic acids of microorganisms. Ethylene oxide has an alkylating effect on proteins and DNA, while formaldehyde causes irreversible changes to amino acids and nucleic acid bases. This mechanism is particularly useful for sterilizing medical equipment that cannot withstand high temperatures or moisture. Finally, oxidation is a powerful mechanism used by disinfectants like hydrogen peroxide and halogen compounds. Hydrogen peroxide produces hydroxyl-free radicals that attack membrane lipids, DNA, and other cell components. Halogenate compounds such as povidone iodine oxidize sulfhydryl groups in proteins, leading to microbial death. These agents are widely used for surface disinfection and wound care due to their broad effectiveness. Summary: disinfectants and antiseptics are essential tools in infection control, each with specific uses and mechanisms of action. Disinfectants are for inanimate objects, while antiseptics are safe for living tissues. Understanding their classifications, ideal properties, and how they work helps us choose the right agent for every situation. By applying this knowledge, we can effectively reduce the risk of infection and promote a safer, healthier environment for everyone.